Graphs of circles look very similar to quadratics. However, they follow a general rule of x squared plus y squared equals r squared. So if you look at this equation, it looks very similar to Pythagoras' theorem, and there's a very good reason for that. I've just got a little applet here that I can show you what happens. So if you've got x being one short side and y being another, okay, the hypotenuse, okay, x squared plus y squared is going to equal this squared. Okay, so you can see that wherever I rotate this around the origin, okay, it always the radius always stay the same, and x and y always stay the same. Okay, so that's why graph of circles look like that. So back to the formula. Okay, x and y are variables. The x and y plane are axes, and the r squared is going to be, or r will be, the radius. Okay, so of the circle. Go for it. So, for example, a circular radius 4 centimeter will have the formula of x squared plus y squared equals 4 squared, also known as 16. Okay, it won't be in this form. You often have to square root it to find the radius. Now, example question. One of these might ask you this. Okay, so for the equation, this one here, complete the following. So state the coordinates of the center. Okay, so basically for every circle in this form, the coordinates are going to be the origin. So the coordinates of the origin is 0, 0. Okay, it always starts right in the center. Okay, now the radius. Now, as stated before, the x squared plus y squared equals the radius squared. So in this case, we can say r squared equals 4. All right. Therefore, r is the square root of 4, which is 2. Okay, so that will give us a radius 2. Okay, find the values of y when x equals 1. So this is telling us to sub in x equals 1 and solve for y. Okay, so we use our this formula here, and we're going to substitute in 1 for where we see x. Okay, so 1 squared plus y squared equals 4. Alright, so let's work through this. 1 squared is 1, plus y squared is going to equal 4. Now to get y on its own, we have to take away 1 from both sides, and we get 3. Now, this is where it gets a little bit tricky. If you haven't done this before, it might get a little bit confusing, but when we take the square root, I actually mucked up a bit up the top there, but when we take the square root of any number, any positive number, okay, so the square root of 3, two answers can happen. It can be positive and negative, and this is where you see these plus or minus signs. Okay, so plus or minus square root of 3. Right, so there's two answers. It can be positive square root of 3 and negative square root of 3. Okay, and that goes for all positive square root numbers. So the next sample question asks us to find the values of x when y equals 1/2. Okay, so now we're going to do the opposite. We're going to say we're going to sub in y equals 1/2 and solve for x. Solve for x. Okay, so this is going to be a little bit trickier because it's a fraction, but it's the same method. We will say x squared plus 1/2 squared equals 4. Okay, I've just used my original equation. Now, using our power laws, okay, we can say, well, 1/2 times 1/2 is 1/4 equals 4. Now, to get rid of the quarter, I take it away. Oops. Okay, so it gives me x equals, now 4 take away 1/4 is going to be 3 3/4. Okay, so it might be useful to actually think of that as a mixed number. So as a mixed number, 3 times 4 is 12, 12 plus 3 is 15. So we're going to get 15 over 4. Now taking the square root of both sides, we get the square root of 15 over 4, or the positive and negative of square root 15 over 4. We simplify where we can. Okay, so it'll be square root of 15 over the square root of 4 plus and minus that. Square root of 15 cannot be simplified, but the square root of 4 can, so that's 2. Alright, so again we've got two answers there, plus or minus the square root of 15 over 2. Finally, we're asked to sketch a graph showing intercepts. So if we know that it is in this form here, okay, we are going to be able to tell that it's a circle, okay, and it has a radius of 2. So pretty much that's all we need. So we're going to be, I'll see if I can draw a circle here. So let's see if I can go like this. Okay, so it's not perfect, but it's pretty good. And the intercepts are going to be, obviously, if it's a radius 2, that's going to be positive 2, and negative 2 in both directions. Okay, this being x and this being y. Okay, so that's how we graph a circle. You can find various points along here by substituting in different values, but that's pretty much it for that.